Hello, I am Dr. Ray Weymann, and the following video is a talk I gave at the First Presbyterian Church in San Luis Obispo. It is the first of 5 on climate change, its impact, and solutions. The following 4 will be given by meteorologist John Lindsay, Dr. Steve Hansen on health impacts, Dr. Louis Patelka on ecological impacts, and Sharon Ripner of the Citizens Climate Lobby. Well, I have up here my website and my email address, and the reason I'm videotaping this is not because of its great historical importance, but because I will be making references to some books, which I see I left down below. But Karen, maybe you could bring those 2 things up front. And I want you to be able to access those and not have to scribble down while I'm talking the websites. Let me also mention, because I don't think Karen mentioned this, although maybe I wasn't paying attention, this is the first of 5 talks by colleagues of mine, of whom one is here. The second one will be my very good friend, John Lindsay, who will be talking about climate impacts. Now, John, I have to tell you, there'll be a little overlap with what I'm going to say, but not as much detail as I'm sure you will go into. And then the third one is by Dr. Steve Hansen. I don't know if Steve is here or not today, who is an expert on the health impacts of climate change, and that indeed is one of the real issues that we've got to come to grips with. And then the fourth would be my friend Dr. Louis Patelka, who is an ecologist affiliated with a network called the NEON Network, which monitors ecological systems over the United States, and that's very relevant also. And then the last one will be Sharon Ripner, who's one of the leaders of what is called the Citizens Climate Lobby, and she will be talking about what citizens are doing to try and get bipartisan efforts involved in the climate change. Now, I'm going to be skipping over some material, otherwise we would run too late, but let me just get started over some of the main issues. Unfortunately, this topic, as I think you are all aware, has become heavily politicized. That's really unfortunate because Republicans and Democrats don't argue over gravity. But the basic science of climate change is as well established as gravity, not in minute detail, but the basics are very, very clear. And yet you can see from these quotes up here from the new EPA administrator, Scott Pruitt, there's tremendous disagreement about the degree of climate change impact. And he says, I would not agree that carbon dioxide is a primary contributor to global warming. No climate scientist that I know of would agree with what he has just said. The evidence that humans are causing the climate to change is overwhelming. Then Director of the budget, Mick Mulvaney, says we're not spending money on climate change research anymore. We consider that to be a waste of your money. These 2 statements strike me as rather contradictory. On the one hand, some person is complaining about the fact that we don't understand everything, and the second person says, let's not spend any money to understand things better. But that's the way it goes. Now, in fact, the public is under the impression that there is quite a disagreement among climate scientists on whether humans are causing the climate to change. And in fact, that's contrary to what several surveys have showed, where it's nearly unanimous that indeed scientists are in agreement. This mismatch between what the public thinks, climate scientists think, is no accident, because there has been a significant effort on the part of the fossil fuel industry and some of the think tanks that they sponsor to create this impression, just as many years ago there was an effort by the tobacco industry to say, oh, we don't agree on the science, we need to study it more, we don't understand things well enough. And that's false. So I want to now get on to some of the very basics about climate science. So when you talk to your friends and neighbors and they say, well, what is this? Hasn't climate always changed? And gee, it was hot last year and cold this year, and what's this, all this got to do with climate change? But we have to therefore distinguish between what we call weather and what we call climate. Now, John issues weather forecasts every day. Sometimes it rains, sometimes it doesn't rain, sometimes it's hot, sometimes it's cold, and those day-by-day changes are what we call weather. And in fact, they're really weather that lasts over a couple of years. I imagine John will talk about El Nino and La Nina, which you've all heard about. And that, in a sense, is long-term weather lasting maybe 2, 3, 4, 5 years. But by climate, what we mean is the long-term average of weather, and long-term means maybe 30 years or so. And so the question is, what causes not the weather to change, but what causes the climate to change? And the answer to that I always like to summarize in this little cartoon. All of you at home probably have some kind of accounting. You have a checking account or a savings account, so you have to have an accounting of what comes in and what goes out, and the climate system is the same way. In this little diagram here, sunlight, of course, is what gives the Earth its energy, and we know that sunlight comes down. That's represented by the green arrows, and some of that is reflected back out into outer space by the yellow bar representing clouds and snow and ice and other surfaces. But about 70% of it strikes the surface of the Earth, the land and the ocean, and that absorbs the heat, and that's why we're comfortably warm. Now, every object, whether it's you or the ground or the Earth's surface, gives off energy because it's a warm object, even though our eyes can't see it. And that energy is called infrared radiation, the same thing that your motion sensors detect. And that infrared radiation flows back out into space, but some of it runs into special molecules in the atmosphere called greenhouse gas molecules. And the important one for our discussion is carbon dioxide. When that infrared radiation bounces off one of these molecules, some of it may be returned back down towards Earth, and others may be sent out into space. And that additional radiation sent down to the Earth is what warms the Earth over what it would be in the absence of the greenhouse gases. That's a good thing, because if there were no greenhouse gases in the atmosphere, Earth would be one gigantic snowball at about 0 degrees Fahrenheit. So to convince you that, in fact, next slide, there we go, carbon dioxide really does this. This is a little video, and we'll get it started in just a second. But what you'll see is an experiment where this young Scottish scientist with a delightful Scottish accent describes an infrared camera which is going to sense the energy sent to it from a candle. But of course, we can also see the candle in visible light with our eyes. And then he's going to pour carbon dioxide into that tube, and you'll see that some of the infrared radiation then doesn't reach the camera anymore. So Barbara, why don't you start that video?
I can show you how carbon dioxide affects Earth's climate using this heat-sensitive or infrared camera which is purring away here. And a candle, this glass tube, which is hooked up to this rather large canister of carbon dioxide gas. Now if I light the candle, you'll see that on the monitor, the camera picks up the flame perfectly. Look at that. The hottest parts are glowing white. Now watch what happens when I turn on the carbon dioxide. Just keep your eye on the flame.
Now what the infrared camera is seeing.
The gas is invisible, so you don't see it fill in the tube. But as it comes in, you should see the candle start to disappear. There it goes. Look at that. What's happening is that the carbon dioxide in the tube is effectively trapping the heat.
Okay, so Barbara, next slide, please. What have we seen during the last 10,000 years? People say, Ray, you show too many graphs, and that confuses people, so I'll try and keep them to a minimum. But graphs are the language of science, so I do have to show a few of them. And what this graph shows is the record of carbon dioxide going back from the present 10,000 years. How can you measure something like that over 10,000 years? Well, in the ice sheets of Antarctica and Greenland, little air bubbles are trapped, and you can measure what the carbon dioxide level was in the atmosphere at the time those layers of ice were deposited, just like you can count tree rings. And you can see that all of a sudden, when direct measurements were made, it rockets up here. In fact, since this slide was made, I've had to add this little red dot because it's grown so rapidly. So this, because of the basic laws of physics that I discussed just a few moments ago, this means that the Earth must warm. And this is not a new idea. It isn't something which scientists dreamt up just a few years ago. Way back in 1896, a scientist said, look, we understand that as we burn more fossil fuels, we're going to increase the carbon dioxide and the Earth will get warmer. Now, we've learned a lot in the meantime, but that was the basic idea, and it's not a new one. So what are some of the effects of a changing climate that we're seeing already? And here's where I'm going to overlap just a little bit with John, but I think repetition is good for the soul, isn't it, John? All right, well, first of all, the most obvious one is that the Earth's surface as a whole is getting warmer. And here's another graph. And what it's showing is starting back in 1880, which was when we were able to measure an average global temperature, the Earth's temperature, it went up and down, it wiggled around back and forth and back and forth. And beginning in around 1970, when the developing nations and Europe recovering from the war began really to industrialize, it took off like a rocket. 2014 was the all-time record ever since these records began. 2015 broke that record, and 2016 broke that record. So that's an obvious measure of a changing climate. But that's really just the tail on a great big dog, and the great big dog is the ocean. The ocean gains about 40 times more heat than the atmosphere does. Of course, it's a huge, huge deposit of absorbing material. And one more video to get started. You're now going to see a little demonstration which John and I have done many times. I don't know if there are any teachers in the audience or you have children who are teachers, but if you do, this is a wonderful thing to do for kids. Kids love to see this experiment, and John and I have done it many times and always love it.
Climate change is something that affects all of our lives, whether we're a student, a teacher, or a scientist. And speaking of scientists, I have a guest here with me today that can tell us a lot more about climate change, Josh Willis. Now, you're an oceanographer here at JPL, correct?
Well, I'm an oceanographer, but I study sea level rise and global warming and really how the ocean fits into that whole global warming picture.
Heat is trapped in our atmosphere, but is it also affecting the oceans?
It turns out that 80 to 90% of the heat from global warming is actually going into the oceans. So the oceans are really the big Earth heat bucket. That's where all the heat winds up going. It turns out that the oceans can absorb 1,000 times the amount of heat as the atmosphere without really changing their temperature all that much. And the reason is because of something called heat capacity.
Do you have an example that could maybe explain heat capacity?
Let's imagine that this balloon represents the whole Earth's atmosphere. So now my candle, my little lighter here represents the sun, so let's add some heat to it and see what happens.
Now don't try this at home without adult supervision and proper safety equipment. Whoa! So obviously the heat capacity of air is very low because it didn't absorb any heat at all.
Well, that's right. Almost as soon as we put the candle to the balloon, it exploded. And the reason is because since the air inside the balloon couldn't really absorb the heat that fast, all the heat went toward melting the rubber. As soon as the rubber melted, the balloon explodes.
Ah, okay, cool. Now that's a good demonstration of the heat capacity of air. How about the heat capacity of water or the oceans?
Yeah, let's do the oceans. How about a water balloon, Steve?
Sounds great.
All right. All right, Steve, so this balloon filled with water represents the oceans, and my lighter here represents the sun. Let's put some heat on it and see what happens.
Wow. Obviously, it's absorbing a great deal of heat.
Right, so you feeling the heat there, Steve?
I am.
All right, but the balloon really isn't, because it turns out that the water can absorb so much heat that it takes the heat away from the skin of the balloon before the rubber can melt, so the balloon doesn't pop.
Now, since John will describe weather effects, I'm going to run through these very quickly. I will just say, warmer air can hold more moisture. Warmer ocean will cause more water to evaporate. That means that when it does rain, we can now expect more intense precipitation events. This was a disastrous flood back in Louisiana, and that's just a sign of things to come. We also know that a warmer ocean can trigger more intense tropical storms. This one hit the Philippines a few years ago with winds that approached 200 miles an hour, the strongest ever recorded on landfall. But there are other less spectacular events, and Dr. Patelka may describe some of these. Because of the warmer winters and drought, beetles are existing to last over the winter, and they spawn new generations which cause beetle infestation. They're ruining millions and millions of acres of forest. John, are you going to show this chasing ice video? Okay, I'll just show just a little bit of it.
I'm on the phone with Jim on one of our regular check-ins. Like, Jim, nothing's happening.
Hey, Jim. It's going well. We had some serious bouts of wind, but other than that, things are fairly well set up here. We've got some continuous time lapse going.
It's starting, Adam. I think. Adam, it's starting.
Oh wait, Jim, this is the big piece is starting to cast. Let me call you back.
Call him back.
Okay, bye.
Still going? Yeah. In that V section right there. Holy shit, look at that big bird rolling. All four running, right?
Yeah. Look at that. You see how, look at the whole thing.
Well, this goes on for a few minutes, but it's a wonderful trailer to a documentary film called Chasing Ice, and the documentary filmmaker is James Balog, B-A-L-O-G. The point I want to emphasize is that these things that are occurring are not occurring at a constant rate. They're accelerating, and you can see that it took 100 years for the glacier to retreat from here to here, but in just the next 10 years, it moved that far. So things are speeding up in a hurry. This moving of land ice into the ocean, coupled with the warming ocean, is causing sea levels to rise, and that's an issue for places all over the world. The major cities on the coast all over the world will be impacted by sea level rise. Now, I don't mean to say that every single event like drought or heat waves can be attributed directly to global warming. And to illustrate that, I don't know if there are any baseball fans in the audience or not. Anybody follow baseball? And you remember back in the 1990s, all of a sudden there were a whole bunch of home runs hit. Now this is Barry Bonds breaking the all-time home run record. He hit his 73rd home run. We now know that all those home runs took place during the steroid era. But we can't say that every time Barry hit a home run it was because he was taking steroids. But what we can say is that increased the odds that when he connected it would be a home run. And that's what's happening with our atmosphere. We're throwing up this extra insulating blanket of carbon dioxide, and that's putting our climate on steroids. And so it's changing the odds and the frequency of the events I've mentioned. Now, I'm going to come back to this because, as you all know, there have been recent developments in the issue of the Paris Agreement, so I won't say anything about that right now. But I do want to mention very quickly 6 common fallacies. When you talk to your friends and neighbors, they'll say, oh, but hasn't climate always changed before? Yes, it has. But the important difference is that now our human activities are causing it to change over periods of just a few decades, whereas the famous ice ages came and went over periods of tens of thousands of years. So this is a completely different kettle of fish, and you should not let people get away with saying, oh, climate's always changed before. It has, but never like this. Some people will say, oh, but it's the sun. But it's not the sun over the last 50 years. How do we know that? Because satellites have measured the energy from the sun. It wiggles up and down with the sunspot cycle, but basically it hasn't changed, so it's not the sun. Another thing you'll hear is that more warming is good for us. And that's true that plants like carbon dioxide under precisely favorable conditions. But if you don't have enough water, if you don't have enough nutrients, if they're suffering from excessive heat or floods, then of course that's bad for food, and so food security is also another issue. Then there's what I call the 10,000 pennies fallacy, and I love this one because it says, gee, if you look at all the molecules in their atmosphere, which is mostly nitrogen and oxygen, and you look at how many molecules compared to, let's say, 10,000 of those molecules have been added by humans, it's only 1 or 2. And people will say, how could that possibly be that adding 1 or 2 little things could change the climate? That's a very foolish argument. And as John has pointed out, the amount of carbon dioxide in the atmosphere is about the same as the amount of blood alcohol limit in human beings. And you wouldn't want a pilot to set off with as much blood alcohol as now in the carbon dioxide composition of the atmosphere. Or a better analogy still is to think of lead. You've all heard about the lead situation in Flint, Michigan. That is just a few parts per billion of water. And here we're just talking about 400 parts for every million. So to say that something is not important because it's only a small constituent is a very foolish argument. I'm not going to talk about it hasn't warmed since 1998 because you've seen that it has warmed since 1998. And then briefly you will hear also that people in the 1970s predicted an ice age. But in fact that turns out to be overly exaggerated. Only 1 or 2 people thought that might happen, and that's because we were putting soot into the air, and that has a cooling effect. Once the clean air effect came into being, then in fact that was cleared up and we started to warm again rapidly. Now, the economic costs of climate change are very real. So people sometimes say, well, it's going to be too expensive, it's going to be too costly to do something about it. In fact, it will be far more costly to do nothing. And you can see some of the impacts I've mentioned here of doing nothing. Food losses in agriculture, the damage from rising sea levels. I mentioned the timber loss, and Dr. Hansen will talk about healthcare costs. And these costs rapidly increase with warming and outweigh the cost of switching to renewable energies. And I'll mention this program called Risky Business, an analysis done by Michael Bloomberg and his collaborators, and I'll put that in the website. So saying we should do nothing because it'll cost too much, I think is entirely fallacious. The other side of the coin, though, is that in my opinion, we're missing an enormous economic opportunity to try and develop further renewable energy resources. Just this morning, I read about the program in India, which is going to install solar energy to the equivalent of about 80 Diablo Canyon sources in terms of energy output. And where do you suppose they're getting all those solar panels from? Probably China. And so, in fact, we're missing a tremendous opportunity. And you can see here that Asia was the fastest growing region for renewable energy installation, 13% increase in just 1 year. That's quite amazing. Another thing that people say was, shouldn't we wait until we're absolutely certain? The fallacy there is that once we've disturbed the balance of carbon dioxide, it will take hundreds and even thousands of years for that balance to be restored. And in the meantime, we're getting more and more and more warming. So that's a very bad argument to make. Now I'm going to talk mostly a little bit about a couple of goals that California has set. And Sharon Ripner at the last of this series will talk about federal efforts. And people will say, well, why should California bother? Because after all, even though we're a very large economy, only 2% of the emissions come from California. And my answer is that in California there is the political will to do something about it. And if we can succeed in meeting these very ambitious goals, we will show the rest of the world and the rest of the nation that you can have a low carbon economy and still have a very thriving, robust economy. Now, since I'm talking to a constituency here which I think is largely faith-based, I want to mention one other objection which I sometimes encounter. And I have to say, I'm by not the wildest stretch of the imagination a biblical scholar. You heard a statement from Karen, and I'll talk about it in just a moment. But people sometimes tell me, well, isn't it foretold? This is out of the second book of Peter 3:10. The elements shall be melted with heat, and the earth and the works that are in it shall be burned up. And so people say, well, look, if it's foreordained, shouldn't we just throw up our hands and let God take care of it? Or sometimes people like James Imhoff, the senator from Oklahoma, will say it's arrogant of humans to think that they can influence the climate. Clearly we are influencing the climate. And so I want to call your attention to the fact that there is a wonderful link, and again I'll have this on the website, which will point you to statements from every major religious faith in the world, including many, many and almost all Christian denominations, that show how all of these faiths have taken very seriously preserving the environment and the creation for ourselves and for future generations. And the next slide will show the one that came from the Presbyterian statement. This is a different one than Karen read. It's officially passed back in 2008. Heavy reliance on fossil fuels has produced grave threats to justice, peace, and the integrity of creation. And then it goes on to talk about the health risks, which Steve Hansen will show. I want to mention then this book, which I understand is in the library. It's a book by Catherine Hayhoe. She herself is an excellent, respected climate scientist, but she's also an evangelical Christian. And her husband is an evangelical minister. And they've written this book called A Climate for Change. So if you have people who use those arguments that I mentioned, I strongly encourage you to point them toward that book. Now let's talk just very briefly about California, and then I'll wrap it up and we can have some discussion or question. California has set a goal for reduction to 1990 levels by the year 2020 of greenhouse gases, and we will achieve that goal. I think there's no doubt about that. A much more ambitious goal over in 2030 was to drop down to 60% of it and to have 50% of the electricity come from renewables, and then by 2050 an even more ambitious goal to have only 20% of emissions. Now, what are the challenges in meeting that goal? This shows where the emissions come from in California, and you can see that electric power is responsible only for about 20% of that. About 40% comes from transportation, so clearly we need to do something about that. Some come from industrial processes like oil refineries and making cement. So this is a big job we had ahead of us. And I think we can meet it. There are three essential prongs to meeting this goal. One is energy conservation. We can all get by with less energy if we take simple steps like better insulation in our homes and buildings. Then we can generate more and more of electricity from renewable energy resources, and we can convert some of the oil usage and natural gas usage in transportation, for example, when batteries and electric cars become more and more widespread. There's a big elephant in the room, And guess who that elephant is? Now, the obstacle I see to California meeting its goal really is the fact that the federal government may not be very cooperative. But I don't want to leave you with being discouraged, because in fact, I'm quite optimistic about the future. And the reason for that is that in fact, California is just one of almost 30 other states that has set their own renewable portfolios for clean energy. And in fact, we're forming even more robust partnerships. Governor Brown just left on a trip to China to try and work out common standards for electric vehicles. So I think there is hope. In addition, there are many cities around the world, and San Luis Obispo is one of them, that are part of something called the Global Covenant of Mayors for Climate and Energy. They are committed, as are many huge metropolises around the world, to reducing their carbon footprint. And in fact, the mayor now, Heidi Harmon, has set a goal of having San Luis Obispo carbon neutral in the future. So I am very optimistic that we will make some progress. And I want to also mention finally one other little book. It's a brand new one by Michael Bloomberg and Carl Pope. Carl Pope, if you recognize that name, was a past president of the Sierra Club. And you may say, gee, that's kind of a strange bedfellows for the Sierra Club, which used to be regarded as kind of crazy, far-out, tree-hugging types, and Michael Bloomberg, a solid citizen. But in fact, they're really very much on the same page. And their point is that cities are leading the way to a clean energy future. And let me just read the one paragraph and then we'll quit. We can stop global warming, not by slowing down economies, but by speeding them up. Not by depending on national governments, but by empowering citizens, businesses, and citizens. And I think there is hope for that, and you'll hear more about bipartisan efforts from Sharon Ripner. So let me stop there, and if you want to make any comments or ask some questions, I'll do my best to answer them. Thank you very much.